term that, okay, so it will give you a bias term that, it's very similar to what should be recommended. So beyond the average, there are two main methods. One of them is the user-based collaborative filtering, and the other one being the item-based collaborative filtering. And the user-based collaborative filtering, what it simply does is, if we're trying to make a prediction for user 3, we're trying to predict how this user would like this item, we would first of all find similar users. And after I send the slide over, you can do a check. User 1 here tends to have similar items to user 3, and then user 5 here also has a similar profile as user 3. You can see 4, 4 there, 4 and 4 there. It takes a while to kind of go through it. Now, if we find the similar users, then we take the average of 3 and 3 in there, and then we put that into here. So it's very likely that user 3 would give this a 3 because all his friends or people like him had given it a 3. Likewise, the item-based CFP reverses the case. So we start with the item, we look for items similar to the one that the user is trying to predict, and then we go to find the users that have rated those items, and then we compute the average that they had given to that particular item. That's it. We don't use that. This is the most naive recommender system that you can develop. It's easy, it's a good starting point. But then it doesn't scale really well, because if you imagine how much this would be when you consider sites like Facebook that have billions of users, billions of items, Amazon and rest, this becomes very infeasible quickly. And it's very likely that a lot of these items would be empty. So that brings us to model-based recommenders. And what this means is essentially, instead of relying on raw preference of users, we could learn, just an abstract or a proxy representation called a latent representation. And forget about the math, it's just for illustration and for your study after this. One common technique is called matrix factorization, and you've done this, sometime in school, when you have a single, variable or expression, and then you try to break it into two parts. So this is similar to that rating matrix we've shown. User B has rated item W, user B has rated item Y in there. And this is, a 4x4 matrix. We could break this rating matrix into two smaller matrices, one of them being a user matrix and the other one being an item matrix. And what we effectively learned is that users A preferences can be condensed into 2 dimensions, user B 2 dimension, and then item W 2 dimension. So we've reduced the dimensionality such that if we need to make a prediction, we simply multiply. If we need to predict what B, user B would give for item X, we simply multiply this and this, and that will give us a prediction. So that's matrix factorization in a nutshell. And to move that forward, to accommodate different sources of information, a new branch of recommender system was started, which is the neural recommenders. Now, if you've been paying attention to the news, you'd find that every now and then the buzzword is artificial neural networks. And what these neural networks are good at is automatically learning how to represent items. So if I take a picture of, a jug, for instance, this will be converted to 0 and 1s. But if I needed this jug to be used, in some image recognition algorithm, then I need to learn some smaller representation for it. So when I say smaller representation, I'm talking about a dense format like, the one in there. So neural recommenders are very good. They could work with text, they could work with speech, they could work with videos, and all in all, once they learn something, it ends up being, like this user matrix or this item matrix. So imagine that this whole talk, when it ends up on YouTube, it will just be a list of 0 and 1s in a matrix somewhere. So what these recommenders tend to do generally is to take a user profile, which is just a list of items that the user had liked, and then an item description, which is just a list of how users have interacted or liked that item. and then passes it through a neural network. So very briefly, what a neural network would do is it will apply transformations and then try to predict how much you like that user, how much this user likes this item. And if it makes a mistake, it comes back. If it makes a mistake, it comes back and tells the previous layers how it made a mistake so that it will correct itself in the future. But then, this has spawned different types of architecture, and this is almost like, something really exciting for researchers to come up with new architectures to handle new tasks. One of them is the collaborative variational encoder. But this is, I can deal with this during, question and answer time. What you should know is that when YouTube tells you what to watch, this is what happens behind the scenes. So all the videos you've watched are here. All the things you've searched are here. They are compressed into a learned representation. Your age, your gender, and all the other metadata about you, where you're coming from, you're browsing from Nigeria, from Sokoto, all of that feeds into, this list of values in there. And then a lot of transformation, mathematical transformations, which you don't have to do yourself. It's applied. And once it's applied, YouTube can use it to find videos that are nearer to what you like and then make a recommendation for you. That's it in a nutshell. So I can come back to this later if you want to, but what you need to know is that the beauty of this neural networks is that you can pass in different types of data as opposed to the matrix factorization, which just takes whether a user likes or dislikes a recommendation. So we're almost getting towards like the tricky part. So I'll give you a second to breathe, and then we can go in. It's not tricky as I said it is, but if you've been on Sahara Reporters or if you've been on Spotify, it's very likely that you start your day, you click on Sahara Reporters, I'm looking, or Daily Trust, or any news website you're familiar with. You click on it, and then you start with the story of the news in Abuja. And you may choose to read it, or you may choose not to. It's going to lead you to another link, and you finish going through all the Abuja related news. Then you come back to Sokoto related news, and then you switch to gossip if that's the kind of news you consume. But what will happen is that within a single session on dailytrust.com, whether you know it or you don't, there's normally a sequence of events or a sequence of ways you consume news on dailytrust.com. Or if you're listening to songs, maybe you listen to Indian songs first, then Hausa songs, then rap songs towards the evening. But you do this subconsciously. So if we could predict how these patterns are, then we'll make the experience on this website more interesting for you. So the branch of recommender systems that handles that is called a sequential or session-based recommender. And you can find that in news websites and shopping websites and whatnot. So what they are very good at is predicting the next item that you will consume. And the networks for doing that is really, really ridiculous. But once you get to know it, it makes sense. Essentially, what it's doing is, if this is the first video you're looking at, this is the video you're looking at now, this is the video you've looked at previously, it can learn the relationship by modeling the current item with respect to the previous item. And a lot of transformations happen. And eventually you can, so essentially, given particular V2, you can predict V1, and then you can predict VT plus 1, where T is the time. So it's called a recurrent neural network. And this is very interesting. I'll tell you how all of this ties in. What you need to remember from this slide is that if data or your behavior has a sequential nature, then recommender systems can predict what you'll do next, even before you know that you'll do it. So you've built all of this. How do you know if your recommender system is working? The first step is to decide how you're going to measure it, right? And there are lots of what we call recommendation system metrics for that, like hit ratio, mean recurrent ratio, and NDCG. And essentially what they do is they just give you numbers that allows you to draw graphs like this. So a bad recommender might be the green line, and the good recommender might be a blue line. And if one line is ahead of the other, then it's simply better you choose it. But then you measure it on different dimensions. So one could be recall, one could be, MRR or NDCG. So you choose a baseline, that's what you're trying to compare against, and then an evaluation strategy, how you plan to do that comparison. So in a nutshell, essentially, if you've built a new recommender for Daily Trust that helps Daily Trust put the most interesting news in front of customers, the first thing to do is to choose a baseline. The baseline would be, what if Daily Trust just shows news in a random order? And then you compare random ordered recommendation with your recommender. And if your recommender tends to give you higher metrics than the random one, then you've done a good job. If it's not, then you need to go back and do something better with it. And once you get done with that, you can decide to split Daily Trust workers visitors into two bits, one of them being variation A, one of them being variation B. So you give this 50% the new recommender, and then you give the other 50% the old recommender. And then you check how many clicks do you get, how many people stay, how many people are sending angry emails after that. And the one that has the highest score will be the one that wins. So you're telling them to compete against each other. That is called A/B testing. So the next thing now is you build these recommenders. They are black boxes. You simply see videos or you see news articles. But how are you sure that you should consume them? Why should you interact with them? So the extra step that happens is that these recommender systems tend to produce what we call explanations. And these explanations, here is just like top picks for me because it knows I like this. And then it's picking up these movies for me because it knows I have watched Good Wife. So this movie was recommended because of watching The Good Wife. And now I don't have to start thinking about why is this recommender telling me to watch this? Now I know that it's very likely that Dr. Foster is similar to The Good Wife. And I don't have to think twice. I'll just decide quite quickly and move on. And let's say you're booking a hotel. You're going to Asa Pyramid or Hilton Hotel. This could be an explanation for the hotel where it's telling you that in all the hotels in Abuja, this one has a business center that is 90% better than all the other hotels in Abuja. The transportation service to the airport, is better. But the breakfast here is worse. So you probably, if breakfast is something that is important to you, maybe you should go somewhere else. So you see how explanations can go a level deeper to tell you why you should consume an explanation, a recommendation. But there are lots of reasons why these explanations exist. So how are you sure that this recommender is correct, right? If the recommender is recommending loan applications to you and it's doing it wrongly, maybe because it thinks you are Black, you don't deserve a loan. These explanations can expose biases, and this is what we call scrutability. But the more you see explanations, the more you begin to trust it. Does it help you make the right decisions? Does it help you make the decisions faster? And how satisfied would you be after it? So this is a branch of recommender system that's very interesting in case you want to go. Now, very often you find that on social media, people tend to just believe what their friends share. And this is not surprising because social media is tailored to push stuff that you're very familiar to front and center to you. And if all you're getting is similar information all the time, you will exist in a filter bubble, and that wouldn't allow you to think outside that particular bubble. So there are situations where you want to be in a bubble, but many times it's good to check your own biases. And there's a branch of recommender system that produces these diverse recommendations. And in a nutshell, what they do is once a list of recommendations is generated, you simply take items that are not similar to you, and then you inject them into the list and just add a little flavor to the recommendation. So that would help. So if, for example, you're given recommendations about movies and all the movies are Indian movies, perhaps maybe we should throw in a sports TV show in there or something else to just get you out of doing the same thing all the time. Nobody likes monotony. So this is the most interesting part and the most relevant part to us. Responsible recommenders. So we've gotten to a stage where whether you like it or not, the decisions you make are being influenced by recommender systems, whether you know it or you don't. And if you think about a shopping website like Amazon, there are many stakeholders in there. There's the person selling who wants to maximize profit. You that you're buying, you're trying to minimize cost. Amazon is trying to maximize its own revenue. So you have this multi-stakeholder scenario. And if the recommender system is only favoring one person, then it's unfair. Let's say it's favoring the buyer, then it's likely being unfair to the seller. So how do we ensure that these recommender systems are fair? It's a very interesting area of research. The second one here is the accountability. If today we're making decisions based on recommender systems, like should I buy a car or not? Should I buy a Benz or not? And then this recommender forces me to buy a Benz, and I eventually realize that it's a bad idea. Who do I blame? Do I blame myself, or do I blame the recommender that influenced my thoughts? That's the accountability part of it. And then transparency. What is the minimum that a recommender system should do to establish trust? So these are all ethical concerns that make responsible recommender systems. Now, I was hoping I could get some interesting bit in there, but in the interest of time, I'll just glean over here. I think in 2017, a law came into being called the GDPR. And it's for that reason that once you go into websites, you see all these cookie consent forms that you tend to click. Interestingly, Nigeria also developed something similar called the NDPR. And in a nutshell, what it does is it forces people that that hold your information to be serious about privacy. So if I'm a business and I collect, or if I'm a school like Udus and I collect a list of students, I cannot share that student detail with anyone. Let's say if a parent comes to me and says, what's the grade of my child? He's an undergraduate student. By default, I cannot tell him that because there are laws that stops you from sharing it. Just like MTN will collect your SIM registration details and share it with someone, that is illegal. So these recommender systems need to be designed to cater for such scenarios. And I would go into this if you want more clarity on this, but for now, I'll just move past it so that we have making a lot of time for questions. So how do you get into research? And this is the key slide here. The first thing is to at least pick and choose the few things I've talked about very briefly in this slide. Learn the basics. And then once you learn the basics, don't think of doing something revolutionary. Start by copying what people have done. Once you're comfortable copying what people have done, then try to improve on it. And you improve on it by either combining different approaches or simplifying complicated approaches. And then in many cases, most of what's developed in academia or in labs is just not practical. So what would it have? Well, if you design a recommender for 50 people and you design a recommender for 5 million people, it's a completely different thing. So how do you, make it more practical once it goes there? But I would say the most important thing is to join a community. So I got into this field by luck through Twitter. And till date, I gather all my resources, all my knowledge, and even the jobs I get them through Twitter. So do not hide behind, just academia only. You need to network. It's the bare essential you need to do. And with this, I come in through to my last slide, and thank you for listening. But I have a lot of time for questions, so I'm hoping you'd have some interesting questions to ask. Thank you.
Thank you very much, Dr. Khalil, for the wonderful presentation. I want to acknowledge the presence of Dr. Roko Abubakar, who is the head of Department Computer Sciences, Osman Danfodio University, Sokoto. We welcome you, sir. And we welcome all the students from the university that join, and also other members of the public that join us today in this session. Now we have time for question and answers. We have two ways of going about this. You could either raise up your hand and I will let you unmute your mic, or you can type your question in the chat and I'll read it to the presenter, inshallah. We have MB Umar already. Kindly unmute your mic and say your question.
Thank you, sir, for the privilege we have to have this kind of wonderful presentation. The first question I have, sir, in neural network, where I expected for you to highlight more for us about this neural network recommendation. For what you have already explained, it is diverse. Now, instead of using one user or one item, now neural network try to combine both the user and the item and conduct the system. And from what I read, I know there is different type of this neural network algorithm like CNN, RNN, and ANN. So for CNN, I need to have more highlight on how it works in recommendations.
Okay. Okay, cool. So thanks for that question. So the reason I stepped over neural networks quite quickly is because there is a tendency for us to always think about algorithms all the time. When you talk about recommender systems or any branch of research, the focus is always algorithms, algorithms, algorithms. But I feel, there should be a balance between when you think about recommender systems, when you think about recommender systems, think about algorithms, think about the people, think about ethics, think about presentation. There are so many facets that you need to consider. But to answer your questions about the different types of recommender, yeah, there are, it's a crazy field, and as I've spoken, maybe 2 or 3 papers have been written in neural network. Dr. Yusuf, who is in that area, will tell you there's always someone writing a new paper in neural recommender systems. But when you talk about CNNs or maybe GRU or any of those variants, or even the RNNs, what the neural networks are good at doing is simply learning representation. So they learn, if you can see my cursor here, they're only learning these embeddings, and to learn these embeddings, they need this head, what we call the head, which is the neural networking part that kind of goes back and forth and tells the neural network whether it's doing well or it's not doing well. So if you have a CNN, your CNN will likely be plugged somewhere here. And the only reason why you should have a CNN is if you are dealing with image features. So you have like a list of pictures. A good example is Facebook. I need to recommend friends to you based on pictures you've taken. So at the bottom here, instead of passing this ones and zeros, I will plug in a CNN, which is a convolutional neural network. But what it will end up producing is just, a vector like that, and the vector still passes through neural collaborative filtering. In reality, what's happening here is just the same as matrix factorization. It's a mere dot product that is happening in there. The only difference, so most of these neural networks will, this will be, if you understand neural collaborative filtering, then you've understood half of them. The other half are the variational autoencoders. And I think these are the interesting bits that don't get a lot of attention. So what they do is giving a user profile. So maybe you've liked 4 movies. You see whether you can learn a small representation for it by passing it back and forth until you come in there, as opposed to, having a user and item and then having some sort of ground truth. So I think it's a bit not complicated, but I don't, the time is short. I don't know the composition of the audience. So I don't know if everyone is interested in neural recommenders, but if you feel you want to talk about it at depth, just reach out to me and I'll be able to answer all the questions. It's an area I've spent a lot of time in, but I don't do that as much anymore. Interestingly, there is a debate around how effective these neural networks are, but that's a story for another day. So I'm hoping we can get into that someday.
Thank you, Doctor. Before I allow other people to ask questions, you said that they could contact you. What is the best way of contacting you? Is it via LinkedIn or email or what? So
yeah, you can contact me at Khalil Muhammad at gmail.com, or you can contact me at twitter.com, or you can contact me on, just kind of search for Khalil Muhammad on LinkedIn. So I'm happy, just anything except phone calls. Anyway, so I am the only once you search for Khalil Muhammad and then you search for recommender systems, I'm sure my name will pop up. So just any method you want to contact me, Zoom, Teams, anything.
Thank you. So we have a question on the chat, but before I go to it, I will go with YM Tukur.
Okay.
To ask his question. He has been raising up his hand.
Okay.
Yeah, assalamu alaikum. Am I audible, please, sir?
Yeah.
Yes.
Can I be heard?
Yeah, you are audible, sir.
All right. It's just to thank the organizers and the presenter for a very wonderful presentation. I will say it's really very informative, and just a bit of is it a suggestion, I will say, or observation, because a lot of the more interested audience, mainly PG students, some are looking to get an MSc dissertation topic, or some are thinking to go for a PhD. I think it will be good if maybe, even if it's just superficially, tell the audience where recommender systems stand in machine learning, and possibly why they need to go for the recommender system. For example, it's something to do with prediction. What about the existing machine learning approaches that do predict? How do they fare when compared with recommender system? Why do they have to go for the recommender system rather than sticking to those ones that have been on sort of more clarification? And finally, I think it will be good if certain tools could be recommended, such as maybe Anaconda, Kaggle, stuff that could help them in sort of laboratory, experiments as regards the stuff that they need to do in machine learning. And that was that. But it's a wonderful presentation overall. Thank you.
Thank you very much.
Thank you, Dr. Yusuf. Now I recognize the voice.
So yeah, it's a very vast field, and I wouldn't like to think about machine learning or deep learning or recommender system as different things. I think the field is very convoluted, for a lack of a better word. I think that you would find the application of recommenders in machine learning. Likewise, you'd find a lot of machine learning methods in recommender systems, the clustering approaches, the prediction. Essentially, this layer there, all it's doing is prediction. And I showed the sequence-based one, that's an RNN. So you would find that sometimes when it comes to research, like I was saying, previously, you take one field, what has been done in one field, for example, CNN, and then bridge it over to recommender system to see how you can apply it. Likewise, you can take something like simple diversity and then plug it into either GNNs or any type of neural network. So they go hand in hand. There isn't any, I wouldn't say there's much difference in them. The only difference is that when we think about recommender systems, we must consider that there are people, not machines. You can also recommend to machines, but there are people at the end of the line. So we start with histories and then we end with people. So it's about user experience and it's about some larger goal that you have to. In terms of deciding what you should do for a project, I think it's a very low-hanging fruit for postgraduate students. The first thing is knowing where to find data. You'll find a lot of them on Kaggle or just on Google dataset search. And what I would tend to do is you would find implementations of existing recommenders on GitHub. So once you've learned the basics of recommender systems, what you need to do now is see if you can run a few of them following the instructions. Google has a very good course in that. Coursera has a course in that. It will probably take you a week. And from there, you can pick any of the topics I've talked about here and ask questions. So what, again, I tend to do is, can we simplify? So I think I have it here. So can we combine multiple approaches or can we simplify existing approach? That has always been my approach to solving problems. Or can I make it more practical? And the last research I did was in federated learning. I just didn't have enough time to talk about it. And everyone had been trying to make more accurate models like it's always done in recommender system. And I said, maybe I should make it more practical by making it faster. So it starts with one question. Can I change something about this? And if you change it, that is a research contribution. It doesn't have to be phenomenal. Research takes time. A lot of what we're seeing in recommender systems now had started in like the 80s. And I would say throughout the 90s, things have been slow. Of recent, it's been picking up, but it's also getting slower. So you build one brick at a time until you get to where you want to. In terms of learning resources, email me if you need anything, and I'll compile a few for you.
Thank you. What I will say is, inshallah, we'll get the list of the resources and put them as a description for the video on YouTube. Okay. When we upload this video, we'll try and get them from Dr. Khalil. Still going for people raising of their hands. I will unmute Aminu Muhammad to ask his question.
Okay, thank you very much, Dr. Musab. And first of all, I would like to thank the presenter, Dr. Khalil, for the wonderful presentation there, and also thank the organizers of this great event. And I hope it's an event that will continue for the future. A bit of a question I have here. You did mention about the similarity, and what recommender systems are trying to do is trying to find some items that people are interested in or users are interested in, and they work with similarity. And the ideal or traditional way is try to optimize that similarity, but then that similarity can become too much at some point. So there is the need also for diversity, which is a kind of a trade-off maybe to the similarity. Now, I don't know if you can shed some light into the recent advances in that direction. For instance, what are the methods that are used to introduce this diversity? Should the recommender system just bring in some items that are not really relevant to the user, or what could be some of the methods that are there? Thank you.
Okay, so
thank you.
Yeah, the basic method is called greedy re-ranking. So essentially, everything that is given to you is relevant to you, but it is just that within the cert, things are not as relevant and similar to each other as possible. I'll give you an example. Let's assume that we built a recommender that tells us what to eat, right? Being from the north, you know, there's alele, there's kose, there is tuwo, and all the foods we're used to. We probably aren't used to banga soup and all the edikain kong that you'd find in the south and the east, because, you know, we didn't grow up eating them. We like zobo, but we don't like gilda. And if you think about, in terms of similarity, if all the time you're eating tuwo all the time, it wouldn't make sense. So what will happen is you would get all the items that, or all the food items that you're familiar with in the north, but instead of going from tuwo to shinkafa to pate, you would find tuwo, shinkafa, and then maybe banga soup, which is a bit closer to what you would like, but you wouldn't go for, before things like star and gilda, which is something that you will never go for. So those are completely irrelevant, if you get my point. But within the set, we've tried to not make everything about starchy food. So it could be tuwo, waina, which is completely proteinous, you know, or masa afterwards. So we're just making sure the first item is slightly different from the second item. The second item is very different to the third and the fourth item. And to do that, there's an approach called the greedy re-ranking approach. And that happens after the list of recommendations is presented. But there are other model-driven approaches using either decision boundary. So if you're familiar with nearest neighbors, I'll give you more concrete examples so that the crowd will get that. If we consider a class of APC and PDP supporters, it's a disjoint set. Essentially, you can draw a line. You can't be supporting APC and PDP at the same time. So if you group everyone in a class, you can draw a line between APC and PDP. But those that kind of lean towards, that in PDP that lean towards APC would come closer to the line. Those that are in PDP that tend to like APC would lean closer to the line. That line, let's call it a decision boundary. If I needed to make my set diverse of APC users, I would go to the people that are closest to that line. They are not really APC, they are PDP, but they are very close to APC. And then I'll bring some of them in and push some of them out from APC to PDP. And what I've done is I have diversified it without, making it completely random or completely irrelevant. So that's one of the things.
Thank you very much, Doctor. Just to add that in Nigeria, you have career politicians who are both APC and PDP.
Yeah, that as well.
Okay, I'll take some questions. We have exhausted our hour. It's already 2 minutes past 2. Past 5 rather here in Saudi, which is 2 minutes past 3 in Nigeria. I will take some questions from the text and then inshallah we'll close the session.
Okay.
Ozero Abubakar said, what is the best algorithm for a recommender system?
Best algorithm, okay. Give me a second, let me just get my phone. I think it's ringing, just a second.
Okay. Dr. Yusuf, you are muted, so we can't hear you.
Oh, I said probably somebody needs a children out.
Yeah, what? Yeah. We have some questions here in the chat.
Okay, sorry about that.
Yes, go ahead.
So there isn't a best algorithm for it at all, because what I didn't mention is that for different recommendation tasks, you will need different recommendation algorithms. So if you're trying to predict the next item I'll buy in the shop, then there are many algorithms you would use for that. If you're trying to predict whether me and my family want to watch a particular TV show, that's called a group recommendation. It's different than if only I want to watch a recommended system. And then it depends on the data you have. So this is why once you're selecting a model from recommended systems to machine learning, you decide on the task, you decide on what you're trying to optimize, and then you have N amount of algorithms, try them out, and then you choose the best based on your offline evaluation like I talked about. So there isn't any best one. Sorry to break your heart.
Okay, we'll take, so as I said, we have passed our hour. We'll take, because we didn't start early, we'll take just 7 minutes. Inshallah, we'll finish this session by 10 minutes past 5. Okay. And there's a question here that says, what are the opportunities and constraints of using this recommendation system? A question from Abdullah Ishu.
So the opportunity is revenue, man. It's a lot of money. It's engagement. Is efficiency that has been untapped, and it's everywhere you see. Recently, there was a project we started with a hospital around here, and what it's about cardiology department. So they have a few people that had cancer in a clinic, and not a few, a lot of people that had cancer, but some cancer cases are more advanced than other cancer patients, and some require treatment sooner than later, even if they are not advanced. And then they were trying to prioritize, which treatment or whom the doctors should see first enough, as opposed to just kind of going through this sequentially. So I think they call it triaging within the medical domain. So the hospital realized that they had that problem of prioritization, and they wanted to know if we could build a recommender that prioritizes whom the doctor should see. And this depends on, because there's a shortage of doctors around the world, especially in Western countries. So you would find that Dr. A has a different set of skills, even though he's within that particular area, than Dr. B. And Dr. B is not a consultant, but Dr. C is a consultant. So if Dr. C comes in today, can we tailor the patients he sees to kind of meet what he wants? So there's a million opportunities. Is how you run. When you're running, there's a lot of research in my previous research group that tells you maybe you want to slow down or maybe you want to speed fast. When you use Google Map, that's a recommended system. within our country, it could be, when should you travel on that road so that you don't end up meeting people you don't want to meet on the road? You know, so there are all these opportunities. The constraint, the major constraint there would be the availability of data. So the first step is to know that you have data. If you don't have data, gathering data towards building a recommender system is also building a recommender system. So that will be the major concern.
Okay, so I think before we wrap up this issue, I could see many questions on the text, but I probably will not be able to take them all. I want you, Dr. Khalil, to inform, so as part of the opportunities that you started discussing, I want you to inform the audience, what are the different fields that they could work in? For instance, now you work with Hertz, you work with a company, and if someone has expertise in recommender systems, which are the different jobs opportunities that they could find by having this expertise?
So you would find that in most cases you have data scientist roles, and they pay a lot. I'm not saying that I make a lot, but I'm saying that they pay a lot. So that would be the first one. You could find applied research scientist, and you could be in Facebook, and what you're doing is trying to increase revenue by doing research. The applied data scientist will pick on data and then try to crunch numbers for profit, while the researcher will read books to try to develop new knowledge to do that. But you could also start your own company. So one of it could just be that you collect data from Globacom and then you recommend for people selling hats on the internet. So I think a lot of people underestimate how difficult it is to find recommender systems expert, because machine learning is broad, as you would find out. I'm sure Dr. Yusuf has told you this. So being very narrow-minded and then being in an area where it's directly related to user satisfaction or money, it's the opportunities are endless in there. So yeah, I would say it's a lot. Just check on LinkedIn and you'll be shocked at the amount of jobs you get in there. There's a question from Abba Almul. I have to answer because he was my colleague during my master's. So what are the yes,
Dr. Isbayas.
Yes. Yeah, he was also we were in the same class during the undergraduate. So I would have
oh, we did RG together. Yeah, so yeah. I have to answer.
We have to answer Abal. We have to answer.
So he's asking, what are the advantages of online evaluation over offline evaluations in recommender system? The online evaluation, the advantage is you are testing with real people. So there are no assumptions in there. Offline evaluations, you're using data that you have stored. And if you had collected data before COVID, and then you try to do offline evaluation during COVID, it wouldn't make sense because, for example, nobody's traveling, nobody's renting cars, nobody's, the whole world has changed. The proof is in the pudding. So online evaluation is when you put things in front of people. But because online evaluation is expensive, it takes time. You want to do a lot of offlines to help you narrow down on what you want to put in front of users. So online is always the best if you can afford it.
Thank you very much, Doctor. I think this is where we draw the line. I would like to apologize for people who have sent in questions via the chat. We don't want to go beyond the hour that we have booked for this. Dr. Khalil has some engagements. Dr. Yusuf also has some engagements to manage. And also we want to stop this concept of African time.
But Doctor, just a little interruption. I think we should give the head of department a minute to say something.
Sure. Yeah, Dr. Roko, let me get you to unmute. Let me find. I found his name earlier, but I couldn't see him now. Or is he with Dr. Abba Almuna? I couldn't find Dr. Roko's name. So let me unmute everyone so that.
No, I've seen him.
So,
okay. Okay, go ahead.
Can you hear me now, right?
Yes.
Dr. Musab, thank you very much for organizing this informative lecture. We actually really appreciate you for that, and that I hope we will have another seminar, particularly on how to evaluate recommender algorithm, because specifically that is our problem here in our research group on recommender system. And that I hope you not forget about our request on the current research in network. So thank you very much.
Thank you very much, sir. Surely we will try to get Dr. Khalil back again to discuss that with you.
Okay.
And as I've said at the beginning of the session, because we do this once a month, and for the month of September, we are trying to do research methodologies in computer science. Basically, we try to get experts in this area to discuss the different research methodologies and how to go about research in the field of computer science. But we will see what happens, inshallah, in the upcoming months and weeks. First of all, thank you very much, Dr. Khalil, for giving us your time and your knowledge. We have learned a lot. And I also want to thank my co-organizer of this series, Dr. Yusuf Sani, and also Dr. Roko Abubakar for organizing the students of Osman Danfodio University to be part of the sessions, and all of you who have asked questions, and the ones who have asked but we couldn't get to answer them. Thank you very much. Dr. Khalil has provided different means of contacting him. You could use these means to get in touch with him and ask your questions and guidance for your research. And as we always do, we will put this video on YouTube on our page, and we'll try to get all the resources or links to resources in this area and put them in the description of the link. So you could always visit the link to search. If you want to search, you can just, if you search recent advances in computing on YouTube, it should give you our page, inshallah, where you could get all the details that you need. Thank you very much all for attending, and we will see you in a month again. Bye for now.
Assalamu alaikum.